Hello, everyone. Good morning, afternoon, and evening. Dear authors and invited guests, I welcome you to Technical Session 7F. My name is Amog Dhandere, and I will be moderating this session. And on behalf of the Global Knowledge Research Foundation and GR Scholastic, it is a great pleasure to welcome all of you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2026, Bangkok, Thailand. The 11th edition of this conference is being organized in hybrid mode. The physical event will be held tomorrow in Bangkok, and the virtual event is being held through Zoom from the 9th to the 11th of April 2026. I hope all of you will enjoy the knowledgeable and interactive sessions that we have planned throughout the day. In this particular session, we will be having 10 presentations where each presentation will be given 10 minutes for presenting and 2 minutes for questions and answers. And on the completion of around 9 to 10 minutes, I will be raising a gentle reminder. And there is another request to all the participants that all of you please stay connected with us until the closing remarks are given. And if you have any queries or updates, you can write it to me in the chat box. Uh, Before we move ahead, I would like to introduce our session chairs for today. So our first session chair for today is Fernando Latorre. Fernando Latorre is the Chief Technology Officer at Connecting Solution and Applications Limited in Spain. He is involved in technology leadership, solution architecture, and development of innovative software and digital applications. Sir, we welcome you, and I request you to give us your opening remarks.
Hello, good morning, everyone. Welcome and thank you for joining this session. It's a pleasure to chair this session and to welcome all presenters and attendees. The papers we will hear today reflect a very interesting combination of topics, and together they show how technology research is being applied to practical and highly relevant problems. What brings us together is in a session like this is curiosity, but also the willingness to test ideas, share results, and learn from different perspectives. Conferences such this one is a valuable precisely because they create space for that exchange. Before we begin, I would like to say something to all the speakers. Presenting research is not always easy. It takes effort and confidence to explain your work in front of an academic audience, so please feel comfortable. If you miss a slide or lose a word or something does not come out exactly as planned, do not worry, just continue. What matters is most is the contribution itself, the problem you are addressing, and the discussion your work can inspire. I'm sure this will be an interesting session with ideas that connect theory implementation and possible real-world impact. So let us begin.
Thank you so much for those words, sir. It's great to have you with us. Our next session chair for today is Dr. Jameer Kotwal. Dr. Jameer G. Kotwal is an associate professor in the Department of Computer Engineering at Dr. D.Y. Patil Institute of Technology in Pimpri, Pune, India, with over 14 years of experience in engineering education and research. His research interests include machine learning, deep learning, and AI, with a strong emphasis on real-world applications. His work covers diverse domains such as plant disease detection, facial recognition-based and touchless attendance systems, sign language translation, smart expense management, and emotion-based intelligent chatbots. Sir, I request you to give us your opening remarks.
Yeah, thank you. Thank you so much, sir. First of all, good morning to one and all. And on behalf of Dr. D.Y. Patil Institute of Technology, I congratulate to all the participants as well as the organizer for giving me the opportunity to serve as a session chair for the International Conference on the Information and the Communication Technology for the Intelligence System. So my best wishes for the organizing team as well as the participants. So thank you all.
Thank you very much, sir. Without any further ado, we would now like to move on to our sessions for this, our presentations, pardon me. So our first presenter for today is Thomas KP from the APJ Abdul Kalam Technological University in India. And the title of the research paper is Advanced Sensorless Field-Oriented Control of PMSN using super twisting sliding mode observers for electric vehicle applications. Sir, I request you to kindly unmute yourself and start presenting.
Good morning, everyone. Good morning. Am I audible?
Yes, sir, you are audible.
Sir, I'm having some issues sharing my PPT. So, just 1 second.
Yeah, sure.
I don't know what. 1 second, sir. 1 second.
If you're facing any problems, you can share the PPT with me. I can share it from my side.
No, sir. I'll share. 1 second. It is ready now. Just now. Okay.
Okay, sure, sir.
1 second. Start my presentation. I think it is better. So I will be ready with that presentation too. Okay. So my topic is actually that will be ready. No issues. So I can start introducing my topic. Okay, sir. So my name is Thomas KP. I'm from India. That is, I'm doing research in APJ Abdul Kalam Technical University, and my topic is actually advanced sensor less field oriented control for the PMSM with using the super testing sliding mode
Excuse me,
observer
sir.
for the electric vehicle application. Okay. Yes, sir.
Would it be okay if we
That,
take your presentation next since you are facing some problems with your PPT? Because a
uh,
presentation needs to be shared while you are presenting. That's all.
sir, 1 second. That is sufficient. 1 second.
Would it be okay if we
Because
take your presentation after one of our speakers are done?
yeah, sure, sir. Then it's okay. Then I will wait.
Okay.
I'll wait.
We can do your presentation after this.
B-
Okay. Thank you so much, sir.
okay, sir. Thank you. Thank you. No problem.
Okay. Give me just a
Thank you,
second.
sir. Thanks.
Okay, we can move on to our next speaker in the meantime. So our next speaker for today is Raga Madhuri Dulipudi. I apologize for any mispronunciations. From the Laki Reddy Bali Reddy College of Engineering in India. And the title of the research paper is An Ensemble Voting-Based Model for Reliable Sleep Disorder Classification. Ma'am, I request you to kindly unmute yourself and start presenting.
Good morning, sir. My name is Ragmadari. I am studying final year of my BTech in Lakredi Baladi College of Engineering in India. I'm sharing my PPT. Am I audible, sir?
Yes, you're audible, but your voice is a little low. If you can speak up or fix that, it would be great.
Okay, sir.
Okay. Thank you so much. You can start.
My topic is ensemble voting based model for reliable sleep disorders classification. This done under the guidance of Mr. N.V. Nayak, my senior assistant professor. These are the contents of the project I am going to explain now. Coming to my abstract, we all know sleep is more important for our human health being. So the sleep disorder classification is manual sleep analysis is time consuming and can lead to errors. So automated machine learning solution is highly valuable. The original study compared individual models like KNN, support vector mission, decision tree, random forest, and artificial neural networks. In this project, as an additional improvement, we used voting classifier, which combines multiple machine learning models to make a single final prediction. In this, we used sleep, health, and life data set with 13 entries and 13 features. The features includes age, occupation, physical activities, stress level, daily steps, quality of sleep, and etc. And in this proposed method, we also provide a flask-based web interface for real world usage. Coming to the introduction, sleep is essential for maintaining physical health and mental well-being. And poor sleep quality can lead to health issues such as heart diseases, obesity, diabetes, stress, etc. There are 5 stages of sleep, like wakefulness. It is a resting stage, N1, N2, N3, and REM. REM meant for rapid eye movement, where body in sleeping stage but brain still active. Manual identification of sleep stages is time consuming and may result in inconsistent assessment across experts. With increasing sleep related issues like insomnia and sleep apnea. Insomnia meant for difficulty of falling asleep, and sleep apnea meant for breathing problems during sleep. These automated sleep disorder classification becomes highly important. Machine learning provides a promising solution for this problem. I have gone through the different projects related to my project. Those are classification of sleep disorders using random forest on sleep, health, and life datasets. This mainly focuses only on random forest model, and the next project only focuses on the sleep apnea, and then another project gives is machine learning or deep learning, which gives efficient solutions. In this existing system, only individual model machine learning models are compared, are researched, are evaluated, like KNN support, SVM, decision tree, random forest, artificial neural network. Each model is trained and tested separately. In among these, ANN gives high accuracy, but there is no deployment or interactive interfaces provided in the existing system. The disadvantages of the existing system is they relies on only individual models. Maybe single models may overfit or underperform on certain subsets of data. And there is lack of model combination, reduces prediction stability, and makes classification less reliable. And there is no interactive interface for real world usage. In my proposed system, I introduced a voting classifier to combine multiple machine learning models into a powerful decision making system. Ensemble learning approaches enhances overall prediction stability by utilizing the strength of different algorithms. The model is designed to provide more reliable sleep disorder classification compared to the individual classifiers, and it includes a user-friendly web-based interface. It allows users to input their sleep and lifestyle details and offers secure authentication and displays a predicted sleep disorders if the patient have no disorder or insomnia or apnea. And my proposed system aims to build a practical and accessible and accurate tool to support better screening and diagnosis of sleep disorders. This is the system architecture of my project. This is the first is data layer where we input our data set, and the next it goes to data processing and feature encoding layer. In this, where cleaning and validation and label encoding are done, then it goes to the model training. The dataset is trained and tested uh, for individual models like SVM, KNN, decision tree, and random forest and AN. Those are evaluated. Then the best models are selected. In my case, that is decision tree and random forest. Those are assembled and voted using voting classifier. And then the output goes to the prediction layer. It tells if the patient has no disorder, insomnia, sleep apnea. The output is screened on the web application layer. The requirements of our setting program, our project is machine learning models like SVM, KNN, decision tree, random forest, ANN, and voting classifier. The libraries I used is Pandas, NumPy, Scikit-learn, Matplotlib, Seaborn. UI is designed based on the Flask, and dataset I used is sleep health and life dataset from the Kaggle. Implementation. As I discussed in the system architecture, first is data collection, then I done the data pre-processing, then the label encoding, then the feature target separation, where I have separated the targeted value and the data set separately. Then I have done training and test split. Then I have first trained on the base models like the individual models. Then I done the model evaluation where accuracy, precision, recall, and F1 score are get. Then the model selection is based on the high accuracy models. Then I performed voting classifier, which is soft voting classifier, where the average of probabilities are taken. Then the final prediction is done. It tells if the patient has disorder or not, or if it's insomnia or sleep apnea. The results of my project is this. In this voting classifier, get the highest per accuracy, which is 0.973. And in conclusion, this study shows that machine learning and deep learning can effectively classify sleep disorders. Different models like KNN, SVM, decision trees, and random forest and ANN were tested, each having its own advantages and limitations. The implementation of ensemble method, especially the voting classifier, achieved competitive accuracy while providing more stable and reliable predictions, underscoring the benefit of combining multiple algorithms. This research is not highlights the advancement of in sleep disorder classification, but also emphasizes the importance of integrating user-friendly web interface, such as proposed web-based platform using class to facilitate accessibility and usability for healthcare professionals. Overall, this work helps improve automatic detection of sleep disorders and can support better diagnosis and patient care. Thank you, sir. Thank you for the opportunity.
Okay, thank you so much for your presentation, ma'am. I now ask our session chairs if they have any questions for you.
Okay, sir. No, sir, there is no questions.
Thank you for your presentation. I think it's very interesting. I didn't work with sleep problems in healthcare, but I think it's a very good solution because it's very helpful for professionals, because I have some experience with healthcare related organizations, and tools like these kinds of for improving how to diagnose and to access some patient related data is very interesting. So thank you for the presentation. I think it's very useful.
Thank you, sir.
Dr. Kotwal, any questions for our speaker?
Yeah. How do you handle the class imbalance problem?
Sir?
Class imbalance problem. See, your data set is having just only 413 images. So how you handle the class imbalance?
That is not image data set, sir. That is text data set.
So what exactly the input you have passed?
I have passed the age and the occupation and sleep duration of the patient. There are 13 features.
Okay.
Like gender, occupation, daily steps, stress level, sleep duration, quality of sleep.
Okay, so how you handle the missing data? If say suppose any of the parameter is missing, how you handle those missing data?
I have removed this that if using is null. If there is null, I have removed that if there is inconsistency.
But how you have removed? That's my question, no?
Using like label encoding. After label encoding, we get numerical values.
Okay, fine.
Okay, thank you so much for your presentation, ma'am. Our previous speaker is ready with their presentation, so we can do that right now. So our previous speaker was Thomas KP from the APJ Abdul Kalam Technological University in India, and the title of the research paper is Advanced Sensorless Field-Oriented Control of PMSM using Super Twisting Sliding Mode Observers for Electric Vehicle Applications. Sir, I request you to start presenting.
Thank you. Uh, yeah. Presentation. Sir, 1 second. Presentation. Yeah. Hope my presentation is visible.
Yes, sir, it's visible
Is it?
and you are audible as well, so you can start presenting.
Thank you. Thank you. Thank you. Yeah. Mm, but the presentation is not visible to me. The presentation is actually not visible to me. Anyhow, it is okay. Yeah, first of all, I introduce myself. I am Thomas KP from FPJ Abdul Kalam Technical University. I am doing the research in the area of PMS motor control for the electric vehicles. Okay. And this topic is actually advanced sensorless field oriented control for the PMSM using a super testing sliding mode observer for the electric vehicle application. And these are the index or the topics which I am covering in this presentation. That is abstract introduction and PMS modeling, sliding mode observer, super testing algorithm, super testing. That is the super testing mode observer. That is my proposal. Then the result and discussion. Then the comparative analysis and the conclusion of and the future work and the reference. And coming to the topic, that is actually, as you know, that is PMS means that is a permanent magnetic synchronous motor that is widely using in the electric vehicle because, as we know, normally we were using the induction motor or the DC series motor or any other DC motors we are using in the earlier days, but it was some difficulties with the DC motors. That is, DC motor control is easy, but we will not get the proper efficiency or the that is working in some wide range of the speed. It will be difficult to control all these things. So we are now started with the PMSM or the induction motor with the that is the new controllers. That is a method. Okay, the new, normally we are using the field oriented control for the controlling of the induction motor or the PMS motor. That is the first method. Okay, that is that is the classical control, field oriented control method. That means the field, that means the magnetic field for the motor we can control separately, so that it will be easy to control. Just like a DC motor, we can control the field. That is a condition for the field oriented control. And when we are using this field oriented control, the problem is that is actually we required the mechanical sensors to get the position, the exact position of the rotor. Then only it will be easy. So we need the eliminate we need some mechanical sensors. So the problem is when we are using the sensor, it will be another difficulty that will be making the problems. So to eliminate that, when we are going for the sensorless control for the observer theory, so the sensorless means we need to sensor the back EMF from the motor so that we can identify the position of the rotor. Then the technology is improved. Then we are going with the sliding mode observer, because it can measure the data. That is the strongness of the, that is robustness. That means if there are imperturbations there also, it will be easy to that is handle the data. That is actually sliding mode observer. So sliding mode observer, the strongness is like the strong robustness of the parameter variation and a good disturbance rejection also. But when we are using the sliding mode observer, that is a chattering effect is very high. That means the motor, there is a function actually, that's a mathematical equation. There is a sine function is also coming in the sliding mode observer. That is why it is giving any chattering in that, and noise sensitivity is also higher in the case of a sliding mode observer. So we proposed, that is, we here in the paper we are proposed, that is super testing sliding mode observer, that is SDSMO, that is for this electric vehicle application. So it is reducing the chattering and provide a finite convergence. That means the problem will be converged. That is, the solution we will get in the finite time and improve the estimation accuracy, etc. So it is actually integrated with the field oriented control itself using SVPW, that is space vector modulation. So the performance evaluation that is done, we are actually simulated, and we are getting the an improved response. So coming to the coming to the background, that is actually growing demand of the that is efficient, reliable, and electric drive system is actually required. That is because the sector itself is actually highly demanding. That is the thrust is that is we required a less power or more efficient motors and more efficient control, because the running time or the kilometer, the mileage which we are getting from the battery, which should be increased. So that is why we are going for this type of research. And obviously permanent magnet synchronous motor is widely used. It is high efficiency, high power, high torque density, compact size, excellent dynamic performance. And the classical control is actually field oriented control itself, and it giving the accurate rotor position. The problem with the conventional system, it is actually the rotor position we need to physically measure, then goddess and resolve this. Drawbacks of the mechanical sensor is actually increased system cost, high complexity, reduced stability. So all these problems, that is the problems in the conventional system, that is explained in the papers, that is actually rotor position measurement, and the drawback of the mechanical sensor, that is actually we are eliminated in this paper by using STSMO. And what is the need of the sensorless control? Sensorless control, as you know, that is a mechanical sensor that is having the problems. Then the existing sensorless techniques are back EMF observer, then Kalman's filter, then model reference adaptive frame, and sliding mode observer. All these are this existing sensorless technology, and we are introduced, that is STSMO. Then the proposed solution is actually based on the second order sliding mode observer. And the key advantages of STSM is already I told, that is this reduced the chattering effect and the continuous control of the signal and the finite time convergence and improved robustness. And the objective of this study is actually develop a sensorless control strategy of the PMSM, integrate STSMO with the FOC, then enhance the performance of the EV traction application. Then expected outcome, it is improved torque and speed estimation, reduced noise, and higher efficiency, and better reliability. Okay. And when we are coming to the development of the that is theory, that is we are starting with the PMS modeling, that is the permanent matter, how we are modeling that motor. Modeling means that is actually we are making the dynamic equations in the converted into the two axis, that is alpha and beta axis, that we are express this method actually in the stationary reference frame. So alpha and beta are the reference frame, and we are making the motor model with a stationary reference frame. The other reference models are also there. Rotor reference frame is there, and model adaptive reference frame is there. Synchronous reference frame is there. But here we are modeling our motor in the stationary reference frame model. That is, we are getting the voltage in the two axes. For that equation, we are using the two equations given in this slide. That is V alpha and V beta. So that is the RS is the resistance of the rotor stator, and LS is the inductance, and obviously I alpha is the current component, and E alpha is the back EMF. So this is the modeling of the motor. This is a standard model. Any standard modeling with the stationary reference is same. That's all. Okay. And then the sliding mode observer. Observer means if he wants to measure any parameter in a system, it's a control system. If it is not measurable, we will use an observer. That is another technology. That is actually we will take the input from the standard input, and also we will take the output, and we will observe the specific parameters from that one. That is actually a observer. Observer is a computer system that can observe the unmeasurable quantity in the system. So for that one, we will have a standard equation or the dynamic equation. So when we are observing that one, what will happen? That is actually the observer may be a little bit delay, or it will be giving error after some time only. So we need to get the observer data within short time. It's a small error that is actually we are expecting. That is the observed quantity will be that is fine, and it will be accurate. That is the main objective of the observer. So when we are designing an observer, we need to design the observer with the lower time constant. Also the error should be lower. So here a classical sliding mode observer equation is given. That is the first one, that is di of dt. How we are getting the value, that is the dynamic equation. And in that equation you can see the last time, that is k into sine of I minus I cap. I cap means the referred value. That is, we are the value which we are measuring. And k, that is, there is a sign function. That is why we are getting the high chattering in the sliding mode observer. And the next is actually super testing algorithm. So to avoid this high chattering in the that is SMO, we are using a super testing algorithm. So super testing algorithm, the SMO is actually first order, and super testing algorithm using the second order. That means again the higher order differentiated dynamics we are using, so that we can reduce the reduce the error or the chattering effect. That is why we are using the equation. So we will change the equation into a second order equation, and will make the auxiliary state variables. State variables are no, instead of the primary state variables, we will use the
Excuse me, sir.
yes, sir.
Just a small reminder, 9 minutes are up and you have 2 more minutes of presentation time
Oh,
left.
okay, sir. This is the proposed method for SDSMO. So this is the equation which we are getting, and by using that one, we will improve the one. This is a proposed method technology block diagram. Here you can see the PMS motor, and in the last side, so the observer, the SDSMO, it is actually observing the data from the VM, that is the PMSM, and it is given to a phased local loop, so that you can control by using that the SVPWM, that is a space vector pulse width modulation. We can give the accurate input, okay, by measuring the parameters from the PMSM. That is actually in this method we are doing. And when we are doing this one, these are the parameters. That is the motor model which I taken for the simulation. That is the first one. Okay, motor model is I given, and the control parameters which I given, and these are the results I obtained from the simulation. And when we are comparing the comparative analysis, you can see that the performance, that is the max speed error, the classical SMO is 4.2%, proposed STSMO we are getting 1.6% only. So that is the improvement is actually, or we can, when we are comparing the classical, it is 61%. And the RMS value of the torque ripple, it is 0.92. In the classical SMO, it is only 0.41. So that the 55% improvement in the proposed STSMO. So similarly, the position error, that is 5.8 degree is the position error, that is the rotor position error. And the proposed method, it is 2.1 degree, so 63% it is improved. And the noise sensitivity is also very high in the case of SMO. Here we are getting a low, so it is improved. So these are the results. And the conclusion, that is develop, that is a sensor less FOC strategy for the PMSM, and eliminate the mechanical sensor, so the reduced cost of complexity and maintenance, and provide the accurate rotor position and speed estimation and finite convergence, reduce the chattering and smooth the torque and dynamic response. Also, we are getting a suitable EV traction for the high efficiency. The future scope is actually that is coming to the main limitation, that is actually the experimental validation is actually required for myself, because I simulated only this paper. I need the experimental validation, the real hardware. And the second one is actually in the low speed performance. That is already I got a review also. In the low speed performance, that is high estimation technique, that is the signal injection method is required for the low speed. So near to zero speed, that is the motor is not running, the error will be very, very high. So at that time, this STSMO cannot perform well. So we need to use a signal injection or the high frequency signal injection method for the improvement. That is the one review. Then that is, we need to adapt to the adaptive STSMO gains various operation conditions. Okay, then we can do that one also. The integration with the EV, the actual electric vehicle systems. Then we are coming to these are my references, and that is literature review. So thank you.
Okay, thank you so
Thank you.
much for your presentation, sir.
Thanks.
I would now like to ask our session chairs if they have any questions for you.
My only question is, what kinds of testing or validation will still be needed before this could move from lab to commercially relevant prototype?
Yes, sir. Sir, actually, we are similar to this one, and what we are doing is in the lab, we will set up a hardware setup. That is, we are having a small PMSM motor, and we will make the controller, hardware controller, and we will apply this on this input. Okay, so we will test that one. Then after that, we can apply into the normal EV.
Okay, thank you.
Thanks. Thanks.
See,
Dr.
while doing
Kotwal,
some experimentation, have you observed
Yes, sir.
some torque load variation? In the slides you have mentioned, So
sir,
how
a
you
lot of
handle the
addition is actually
torque
there, but
load
the problem is that,
variations?
yes, sir. Torque load in the simulation.
Yeah, how you
In the
handle?
simulation. Yeah. For in our STS. Yeah. In our STSMO, that is actually the classical SMO method. That is a torque ripple is there due to the sine function. Okay, that is that equation which we given. No, that is in in the classical SMO. That is the last equation. That is k into sine of I minus I cap. That is the equation. That equation actually we will change it into a that is higher order term. Okay, in order to eliminate that one, we will go into the higher order term differential so that we can eliminate the data will be in a different way. That means the observer will give a smooth value. So that is the way we actually the STSMO eliminates the chattering.
Okay, fine.
Okay, thank you so much
Thank you,
for
sir.
your presentation, sir. We will now be moving
Thank you, sir.
on to the next presentation for this session, which will be done by Shaikh Shafi from the B.V. Raju Institute of Technology in India. And the title of the research paper is An Intelligent System for Vehicle Ignition Access and Real-Time Alerting for Theft Prevention in Smart Cities. Sir, I request you to kindly unmute yourself and start presenting. Oh, okay. I think he is absent right now. So we can move on to the next presentation. So our next presentation will be done by T. Gamyashri from the Laki Reddy Bali Reddy College of Engineering in India. And the title of the research paper is Automated Question Paper Generator Using NLP. Ma'am, if you are present, please unmute yourself and start presenting. Okay, she seems to be absent as well. We can move on to the next. So our next one will be done by Seamus Lyons from the Chiang Mai University in Thailand. And the title of the research paper is Comparing Evaluation Metric Sensitivity to Identify Errors in Thai English Machine Translation. Sir, I request you to start presenting.
Someone else is sharing at the moment. Is that right?
Can you try once more? I allowed you to share your screen.
Okay. Can you see my presentation? Hear me correctly?
Yes, your presentation is visible. You are audible as well, so you can start presenting.
Okay. Okay. Just bear with me. Okay. Okay. Good morning. It's morning in Thailand. Today I'm going to talk about my research. My name is Dr. Seamus Lyons, and I work at Chiang Mai University. We start off with the background. My area is machine translation from Thai to English, and this area, the research has dropped. There's less research because in some natural language processing areas like machine translation, performance is very dependent on resources. And with the large language models and Google Translate, how can you compete with their resources? So researchers are finding it difficult in areas like mine. Now, there are free models available, and I wanted to look into the potential of using quality training data rather than quantity. We can't compete with like large language models, Google, etc., on quantity. But at some point, that research, that area will converge and we will need quality. So how can we get quality training data for these free models? For example, in a specific domain would be more competitive. So we're looking at fine-tuning training data and we're looking for the quality training data. So an area that I was looking at was the evaluation metrics for machine translation. The academic publications still refer to the blue metric because we all understand it. But many papers have suggested it's limited, it's not optimal. So we've had historically other similar metrics that deal with some of the issues with blue. And with the increasing use of neural networks, we've got neural-based evaluation metrics as well. So we've got a wide range of evaluation metrics that there's not one that anybody uses. People still refer to the blue score because it's easy to understand, but the blue score has its weaknesses. So in conclusion of this, we basically have a wide set of very different evaluation metrics. So we've used the blue metric to optimize our systems in the past. So what are we going to use now? So there's no one metric that can replace blue. So I wanted to look into the fact that all of these metrics that evaluate how good the performance is of machine translation are so different. Could we use this difference, this diversity, to identify errors in translation and use that information to help create this training data? So let me explain my methodology. When we have machine translation systems and we evaluate them, we tend to use online data. Now, that online data has already been used for training data. So these large systems aren't really translating this text, they're remembering it. So the evaluation is not conclusive. So previous research, I created my own text as an uncontaminated text set, not large, but just to do some research. So we collected some text from books and offline sources, about 50 documents between 75 and 100 words. And then I paid a professional translator to translate that English into Thai. So I had a Thai English parallel text that wasn't available online. So it's relatively a small set, but I can use it to evaluate systems cleanly, if you like, because they haven't seen the text before. Now, I took these texts, these documents, and I put them into the LLM systems and the machine translation systems like Google. So Google is the primary MT system. I did some research about 10 years ago where I looked at what people in Thailand used for translation, and it really boiled down to 5 systems or services, and these 3 are the 3 that still remain. And I looked at 4 LLM systems. So Thai text into these systems online, and then the output is the English text. So that ends up with 50 texts, 7 systems, 350 texts. So with the evaluation metrics, we have the old style metrics that are similar to blue, and I use 5 of these metrics. And the new neural-based metrics, I used 4 of these. So there's a set of 9, okay? So these are the evaluation metrics that we use to determine the performance of the machine translation. So I wanted to see what was the difference or what's the value of each of these metrics against the others. So to use a very simple approach, what I did is I ranked all of the translations in order. So from the best translation, the highest scoring translation, using a metric would be rank 1, and the lowest score would be rank 350. So I had these list of 350 scores for each of the metrics. Now, what happens when one metric is sensitive to some error? It punishes it. So the idea is, you can see here that we have 8 systems that score quite highly and 1 system that scores low. And why does this system specifically punish this translation? Is it an error that we found that the other systems didn't find? So you can see that if we have this deviation, this difference between the average of the other systems and the evaluation metric, then this is potential to find some type of error. So in this example, if, for example, the average score was 80 and some metric score was ranked 200th place, this 120 places meant that that evaluation metric was punishing something that the other metrics were not. So with this information, so I measured the deviation and took the top deviations of all the 9 metrics and then looked at the translations that they identified and then manually checked the translation against the translated output against the correct English text. So the results, first of all, to give you an idea of what I did, here you can see like the top 10 translation where there was a high deviation for the blue metric. And you can just see that there are the number 37 twice, the number 45 twice, the number 13, sorry, 45 and 13 occur 3 times in this top 10, and 37 occurs twice. And the reason why I show you this is, if you look at this diagram, you don't need to worry about the detail. But if we see the blue score at the top, these 13, 37, 45 don't really occur in any of the other metrics. And the reason why I show you this is basically to say that the metrics have a really wide range, really diverse range of translations that they are sensitive to. So there are some connections between like the neural blur and XCOMET. Their top 10 they were sensitive to, punished to. You can see 20 and 25. I think 50 is behind my screen of us. But generally, we have a very diverse set of metrics, which would be good. It's a good sign that this is an approach that could find these errors. So if we take the top deviations, what's the big difference? So here's an example where you can see the top line shows the average of the other systems, and the bottom line, this is, I think, XCOMET on one translation. So if we see the deviation averages about 200 places, so from 1 to 350 is quite a huge difference. So what exactly does this metric punish? What error does this find that the other metrics don't? So I did this with all
Excuse
of
me,
the...
sir.
Yes.
Just a small reminder, you have 2 more minutes of presentation time left. Thank you.
Okay, thank you. So if we look at the text, you will see errors that are not huge, but describe the life is more factual, tell the story is more fictional. And the joint rule and rule alongside are different ways of explaining like the relationship. So other metrics are also, we can see different translation errors by, in this case, the amount of characters. So this metric uses character engrams. And finally, if we want to look at the neural approach, we can see there's some errors that these all are sensitive to, but it's not sensitive to other errors. So we can see that the old surface metrics do find other translation errors that the neural metrics don't. So essentially, we're saying that this approach does identify errors. And that means it's worth looking into using this for training data. Okay. Okay, thank you. Any questions?
Okay, thank you so much for your presentation, sir. Dr. Kotwal and Mr. Latour, any questions?
Yeah, nice presentation, sir. Just I
Thank
want
you.
to know that how the federated learning is mainly used in your project, how it helps.
Well, the idea is that if I take a free model, the performance level is lower than LLMs or Google Translate. If I, first of all, focus on some domain, probably tourism, I need to get fine-tuned data to get the performance at a similar level. So I want to find quality data to be able to improve performance. So the idea is that I use these metrics to create a list of translation errors that systems have a problem with. And then I inform these systems, or the systems that I will create, on perfecting or correcting these errors. Do you see what I mean? When they're training, I'm showing them what the errors are, which they have problems with. So, for example, in Thai, pronouns get taken out, they're omitted in translation, and the translation systems have a problem identifying the pronoun. So this is an issue that with more training data, systems could improve the translation. So given that Thai English is like a low resource language, if we could focus on the actual errors that this approach identifies, then hopefully we can improve the translation performance.
Okay, thank you, sir.
Any more questions for our speaker?
No question for me.
Okay,
Thank
thank
you
you
for
so
the
much for your
presentation.
presentation, sir.
Thank you.
We can now move on to the next presentation. So our next presentation will be done by Xian Ni Thoi from the Ho Chi Minh City in Vietnam. And the title of the research paper is Hybrid Training for Single-Turn Medical Diagnosis with Knowledge Graph. Ma'am, I request you to kindly start presenting.
Okay, can you hear my voice?
Yes, you are audible.
Okay. Is my screen like on the...
Yes, it's visible in the full screen, so you can start presenting.
Okay, so let's start. Good morning, everyone. I'm Giang Thai. Today, I will present our paper, Hybrid Training for Single-Turn Diagnosis with Knowledge Graph, paper ID 1548. So the message of this work is, if we combine knowledge guide supervised fine-tuning with knowledge graph-based reinforcement learning, a small language model became much more reliable and at producing exactly one diagnosis label and is transferred better across the data sets. So why is this problem? Like, symptom-based diagnosis is hard because the same symptoms can point to different diseases, and mistakes do matter in real life situation. And when language models are uncertain, they often produce output that sounds reasonable but are unstable, like extra text, multiple candidates, or disease outside of the allowed list. So we study a strict task, like single turn, single label diagnosis. And the input is a set of symptoms. The output must be exactly one disease name from a fixed vocabulary, nothing else. And for the small models, which is our focus in this study, that constraint is mainly the failure points for most cases, because so our goal is higher accuracy and reliable constraint following and also better generalization. That means like cross data sets transfer. So a natural idea is to use a knowledge graph as feedback. So if the predicted disease is strongly connected to the symptoms, we reward it. If not, we penalize it. This avoids expensive human feedback. But pure reinforcement learning from this signal is inefficient for small models. Early on, the models often output invalid string, and the reward become really sparse, and exploration is wasteful. So our approach is a hybrid pipeline. First, we do a knowledge guide supervised fine-tuning using hard-negative mindfulness graph. Then we use PPO, a RL algorithm starting from that SFT checkpoint using KG consistent rewards, plus an explicit penalty for all the invalid output. So our modeling choice is that the KG is bipartite. That means there's only two type of node and the connection between them is one. So the symptoms and disease are different node types. So we use a bipartite specific semantic model with the BGI rather than a generic GNN reward. So this is the whole pipeline. We built a weighted symptom disease knowledge graph, then compute two signals. The global proximity score with random walks with restart, and a local semantic score with BGI on a query center subgraph. So these signals shape training in two places. The first one is they mine hard negative for the SFT, and second place is they define the PPO reward. So the knowledge graph acts like a structural teacher in some kind. So about the scoring, the global score RWR start from the symptoms and propagate probability through the graph with occasional restart. Disease with high steady state probability are globally close to the symptom set. So RWR is global. So we add a BGI for a local, a more closer structure. For each candidate disease, we extract a small enclosing subgraph around the symptoms and the disease. And the BGI score are compatibility in a way that respects the structure of our dataset. So both components share the same edge weight. We use truncated NPMI weighting, so the common symptoms don't really dominate, and the signal reflects association instead of popularity. So now we step into the first training stage. The standard fine-tuning teaches the correct label, but many diseases are a close competitor under the same symptoms. So the model needs practice to separate these near misses. For example, for a golden correct disease D+, we use RWR to retrieve a top K list of possible disease. Then we choose a hard negative D-, which is a high scoring but not the gold label. So we train the models to produce the correct completion and prefer it over the negative completion, by a large margin. So this sharpen the boundaries exactly where the confusion often occur. So this stage is the main reason the model became strong, even though there is no inference time hint. The second stage, we run PPO. Starting from the SFT choice really matter because the models already follow the output rule. So the PPO doesn't waste sample on invalid format. For each output, we extract the predicted disease by matching against the fixed vocabulary. So the reward combine normalized RWR and BGI score with some smoothing and online normalization to keep the training stable. So we also enforce the constraint with some penalty, like hard penalty, like no valid disease will get a strong negative reward. And multi-diseases are also penalized. And empirically, PPO acts like a structural regularization because it tends to help with transfer even when in-domain gain is practically small. So we evaluate on 3 Chinese diagnosis dataset, GMD, DXY, and METD. So they differ in size and symptom coverage, which help test cross-dataset generalization. Our base model is Gwen 2.5. 0.5b instruct is a known small language model, which is our focus. and we fine-tune efficiently using LoRa. So we compare the base model, the RL only, the SFT only, and the hybrid SFT then RL. We also have two prompting mode. Here you can see in no hint, the model sees only the symptoms and must choose from the full label space, sorry. But here in hint, the team will provide the top K disease from the RWR reward that you see before. So you can see that the no hint is a much more realistic stress test for this whole experience. And here's the in-domain accuracy. The first thing is the hint itself is powerful. You can see the base model improved a lot with hints, which show how narrowing the candidate space helps a small model. And looking at the no hint, the RL only improved only slightly. The SFT with KG hard negative produced a large jump into the mid 70s to the high 70s across dataset. The hybrid pipeline is comparable, slightly higher on GMD. So the interpretation is straightforward, like SFT teach consistent constraint following and is separate confusing disease. So with that foundation, RL struggle because rewards are too sparse and exploration is inefficient. But now this is where the reinforcement learning became more interesting in the cross dataset generalization. When we train one dataset and test on the other, SFT can transfer poorly even when it is strong in domain, like in the correct test dataset. That pattern is consistent with like overfitting to dataset specific correlation. So the table on this slide show that the full train
Excuse
to
me,
test
ma'am.
matrix. Yes.
Just a reminder, 9 minutes are up. You have 2 more minutes of presentation time left. Thank you.
Okay, thank you. So when we add RL to the SFT, the transfer improved 5 out of 6 setting. In 5 out of 6 setting. For example, like training on MAT-D and testing on DXY improved from 32% to 40%. And training from GMD and testing on MAT-D improved from 10 to 15%. There's one counterexample though, training on DXY and testing on GMD, where SFT is better than the hybrid. We view this as a limitation of the KG-based reward for the PPO. So if the KG is narrow or biased, the reward can misalign the distribution shift. So let me close this with some takeaway. Like first, for constrained diagnosis label prediction with small language model, knowledge-based SFT is the key ingredient for strong no-hints performance. Secondly, adding PPO and with a bipartite aware KG reward often improve cross dataset generalization. So RL acts like a structural regularization, like towards the KG consistent decision. And thirdly, our method clearly has some limits. So our KG is a simple co-occurrence graph with one relation, and we only study a small area, which is a single turn, single label settings with a small base model. So extending to richer clinical knowledge source and multi-turn diagnosis would be the natural next steps for this whole experience. So thank you for listening, and I'm happy to take questions.
Thank you so much for your presentation, ma'am. I would now like to ask our session chair if they have any questions for you.
My question is, have you considered testing your approach with other small language models besides Huwen to see whether the method generalizes across different SLMs?
Yes, we have tests, but not to the full extent because we are kind of limiting on computational resources right now. So the test is not being done exhaustively, and we also acknowledge that the only exhaustive test has only been done on this single model, but there are also like nearly completion with Gwen with 1.8 billion parameters, which showed the similar result, as I remember.
Okay, thank you.
See, you're talking
Like
about the hybrid training, right? Every time you're talking about the hybrid training, how you
Yeah.
differentiate between the supervised learning and the pre-trained approaches? How you differentiate your model, the hybrid training?
Can you repeat your questions?
Hello, am I audible?
Can you repeat your questions?
Yeah, I once again repeat. See, you're talking about hybrid training. Hybrid training, fine.
Yeah.
So how you differentiate between the supervised learning and pre-trained approaches?
Pre-trained approaches.
How you
So
differentiate?
in this study, we don't really delve into pre-trained approaches. So gotta admit that our knowledge on that domain is not completed.
And the knowledge graph, you are talking about the knowledge graph, fine. In the particular architecture, where exactly the knowledge graph you have used for extracting the feature or for augmenting the feature, where exactly you have used the knowledge graph?
Okay, so about the knowledge graph is built with the node that are the symptoms and the disease in the data sets. The data sets is actually dialogues, like medical dialogues from real life situation, and it have already been extracted with symptoms and disease, and it's also available like publicly. But the only thing that we have done with the KG build that is different from the previous study that we take inspiration from is we take the co-occurrence, like the frequency of the symptoms and disease happening, to build the weights on the edges.
Okay, thank you.
Okay, thank you so much for your presentation, ma'am. We will now be moving on to the next speaker. So our next speaker for this session is Ochilbek Rachmanov from the Gateway Science Academy of St. Louis in United States. And the title of the research paper is Knowledge Management in Artificial Intelligence-Driven Adaptive Learning. Sir, I request you to kindly unmute yourself and start presenting.
Good morning, everyone. You see my screen?
Yes, your screen is visible and you are audible as well, so you can start.
Hi, my name is Ochilbek Rahmanov. I am participating from Gateway Science Academy, St. Louis, USA. Today's our topic is knowledge management in artificial intelligence-driven adaptive learning. So basically, the problem, in the literature, the effect of AI on students' performance, when we look at the literature, we see that AI is helping for personalized approach. So AI and generative AI enable personalized and adaptive learning paths for the students, which can address students' weak areas. So it's becoming adaptive to the student. So thus many AI platforms in education were produced in recent years because this issue is quite important. So platforms like Alex, Matia, iReady are developed and widely used in K-12 education in USA and in many parts of the world. And mostly they are adaptive AI systems because generative AI is newly flourishing. But I believe that very soon all of them will be generative AI based. But most of them are right now adaptive AI. That's why our research is also based on adaptive AI. So when we look at the researches done before us, we see some mixed findings. Several researchers found that AI has a moderate improvement in achievement. So AI produced data has a moderate improvement on achievement of the students. In one of the studies, there is even the calculation of 0.35 effective size. But there are some major limitations in existing literature. Like most of the researchers are either short study, so they did a study for like just for one exam period or just for one semester, if it's real data, or it is survey-based research. So the research was done on survey. They just ask questions if they believe that the students' performance is improving using AI or not. Same questions were asked to students if they believe that their performance is improved by using AI. So it was just like depending on students' mood. So the data is survey based. It's not real life data. So, what the literature says, there's a lack of real-world performance-based studies. So, like I said, most of them are survey-based. The impact of such platforms on standardized assessments was not yet studied. So, the data produced by adaptive AI was not yet compared. There are not many researchers was not compared to the external exams like national exams. Almost no longitudinal studies was done, like which is spanning for 2-3 years. Like I said, they are mostly done in short time of period, like only for one exam or maybe for just one semester. So mostly like I already stated. So the question is, can AI generated data be used for knowledge management? So we are using AI in education and it's producing the data. So our question is, can we use for knowledge management? Does the AI generate learning data is reliable? If it's reliable and meaningful. So what we wanted to address in this research was, can AI manage data explain students' achievement? Is indeed explaining the student achievement, and do the knowledge indicators translate into measurable and predictive outcomes? So if we can use this data to translate to predictive outcomes. So the design of our research was, firstly, we collected the data from 3 different platforms. All the necessary regulations were followed. So we collaborated with the school management. So we collected the data from the Alex platform, from PowerSchool platform, and from DC. I will explain them. Then we did a data preparation. We convert the data, raw data into the useful metrics, so we can do some statistical analysis and some predictive analysis. Then we did some learning analytics. It was mainly descriptive and correlations analysis. Then we tried to do a predictive modeling. We just tried to test if it's possible to use the data produced by the AI and to do some predictive modeling like a regression and classification test. Then we did an evaluation on that, and we had a conclusion on AI-generated learning data, so if it's helpful or not. So basically, like I said, we use 3 platforms, so I will quickly go through them for you. So this is the Alex. This is AI adaptive learning system for students. We concentrate ourselves on only one subject, but the same study can be adapted for any different kind of subject. So it's Algebra 1 subject. So this is the system for Algebra 1. So students usually see this. So there are 2 paths for the student. The first one is dark area in here. You see their teacher can assign assignments, can give homeworks, or can conduct some of the quizzes. So this is curriculum-based part of this system. And there's bright side in here, continue my path. As you see in here, it's adaptive AI. So student is just clicking and the system learning the weaknesses of the student and offering student to study the topics which he is weak on or the topics he doesn't know. So in the beginning of the year, this number, like this circle should be completed by the end of the year. Usually it's not being completed 100% because nothing is perfect. So in the beginning of the year, we have a number like 100. And by the end of the year, we're expecting our students to reach like 300 or more than 300. So what's this number? This is number of topics students should learn throughout that year. So this is the Alex platform, which produce adaptive AI results. We use the PowerSchool, where students are just doing their curricular activities and getting their grades. So they have grades for semester 1 and semester 2. And finally, we collect their data for the state examinations. So they said for the Algebra 1 state examination. So as a result of that examination, they have a scale report. So their scores on that exam and their level on that exam. So usually it's advanced, based, proficient, advanced, basic, proficient, or below basic. So these are the main data source we collect the data. So our sample data set looks like this. So it's they identified all the students for the privacy. So we have an initial knowledge check on Alex. Then at the beginning of the year, at the end of the year, we have final knowledge check on the Alex. We have the time, how many minutes they spent throughout the year on Alex. We have their semester 1 and semester 2 score coming from the curriculum. And we have their state examination results. and we have their state examination results classified into the performance levels like advanced, proficient, basic, and below basic. So here's the metadata. So this one is ranged from 0 to 1. From 0 to 1, this one is ranging from 0 to 27,000. This one is ranging from 0 to 100, 0 to 100. This one range from 200 to 450. And this one has only 4 classes. It's below basic, basic, proficient, and advanced. So this study is longitudinal study. We collect this data for 3 years. So it's for 3 academic years. Total 182 students participate. Their data was collected, and majorly they are grade 9 and 10 because Algebra 1 is offered for grade 9 and 10 in USA. So firstly, we did some learning analytics on the data. So we look into the ALEX itself. So knowledge mastery increased across the years. So every year we saw that knowledge mastery is increasing. That means the platform is being used better and better by our students. The knowledge check growth, we compared the difference between initial knowledge check and the final knowledge check, and we saw that it's improved yearly. So every year it was improving, but there's a limitation. Variation suggests that unequal students benefit. So it's not like all students are benefiting samely from this platform. So then we did a correlation analysis on this
Excuse
data.
me, sir.
Yeah.
Just a small reminder that 9 minutes are up. You have 2 more minutes of presentation time left.
All right.
Thank you.
We did a correlation study, and we saw that the final knowledge check is correlated with the semester 2, and initial knowledge check is correlated to semester 1. Samely, final knowledge check is correlated to the state examination. They are moderate, but they are correlated. Next, we did multivariable linear regression. We saw that some of the variables are significant predictors, and some of them they are very weak predictors. But the variance was very low. It's because we didn't include any background data of the students. Then we did a classification analysis on this to predict the students' state examination results. We employed random forest. We saw that the classification accuracy of random forest was 41% and F1 score was 39. So the model was best performing on below basic students, so it was identifying below basic perfectly, and the best predictor was final knowledge check. So it's again coming from Alex. Of course, there was some limitations during the development of this model. So the accuracy is moderate, still moderate, and we had a limited number of predictors, but still we saw that the data coming from AI generated platform is quite important. So what are the key results we found? The first key result is final knowledge mastery correlated with state examination, which is quite important. We also saw that regression shows that knowledge indicators predict academic performance, even if it's not very strong, but still they have a strong relationship. And we saw that the mastery metrics stronger predictors than time on test. So we saw that spending time on these platforms not really affecting anything. It's only number of topics they have finished is important. So what's our contribution to the literature? This study provides real-world performance-based evidence beyond the surveys. Secondly, we bridge the gap between adaptive learning data and standardized test outcomes. Third, we validate AI-generated data as knowledge management indicator, so indeed it's reliable and can be used. And finally, this study integrates learning analytics with predictive modeling. So the data produced by AI platforms, if it's used wisely, can be indeed used for predictive modeling. This is our literature review. And if you have any questions, please.
Thank you so much for your presentation. I would now like to ask our session chairs if they have any questions for you.
Can the system be used in the real time for assessing the students?
For that, you need to use some kind of API to extract this data. This data is continuously changing. This is final. It never changed, but these two continuously changing. Yeah, if you use some kind of API and develop a system definitely you can make it real time.
Okay, and one last question. See, you are collecting the data for the various courses, might be algebra, mathematics, science, right? If say suppose any missing data has been there, missing as well as the noisy data, how you are going to fill those particular data?
So since this is demand from the Education Minister of Education, it doesn't have a missing data. Like students should have complete this all the stuff to graduate, and student has to complete all the stuff to graduate. So if anything is missing, we need to eliminate the student because he is not satisfying the Missouri standards.
Mr. Latour, any questions?
Yeah, only question is which parts of the study were based on random forest classification or in other kinds of classification?
So, like I said, the main idea of the research was to see if the data produced by adaptive AI and platforms can be used for classification. We didn't really try our best to develop a perfect classification model. We just tried some great research on random forest and on decision tree. And so to see if this data can be used or not. Definitely a further study can be done to develop a better classification models with more predictors.
Okay, thank you. Thank you very much.
Thank you.
Okay, thank you so much for your presentation, sir. We can now move on to our next speaker for today. So our next speaker is Akshay Kumar from the Datta Meghe Institute of Higher Education and Research in India. And the title of the research paper is Modern Approaches to Crop Monitoring, Enhancing Productivity and Sustainability. Sir, I request you to kindly unmute yourself and start presenting. The title of the research paper is Optimized GAN-Based Data Augmentation for Enhanced Lung Cancer CT Classification. Ma'am, I request you to start presenting, please. Okay, she seems to be absent as well. We can move on to our next speaker. So our next speaker would be Akshay Kumar from the SRM Institute of Science and Technology in India. And the title of the research paper is Privacy Aware Multi-Cloud Task Scheduling Using Federated Learning. Sir, I request you to kindly unmute yourself and start presenting.
Hello, good morning, everyone. Let me share my screen. So, I am Akshay Kumar. I'm doing MTech in Cloud Computing, working under the guidance of K. Deepa Tilak. Today, I will be presenting my research titled Privacy Aware Multi-Cloud Task Scheduling Using Federated Learning. So, this work focuses on how we can efficiently schedule real-time smart mobility workload across the cloud providers without compromising the data privacy. So our today's agenda will be like I will begin by explaining the motivation behind the work and the problem we aim to solve. Then I will briefly discuss about my research objectives and the proposed architecture and methodology. And then I will be moving to experimental results, conclusion, and the future scope. So in the modern smart city applications such as intelligent traffic management, vehicles navigation, and IoT-based mobility systems generate huge volume of real-time data. As we know that we are getting the data from the sensors in the real time. And this data is latency sensitive and geographically distributed. We have to take a decision must be made very close where the data is generated, from where we are getting the data. So for the traditional single cloud architecture, we generally struggle with the high network latency, scalability limits, vendor lock-in, single point of failures. But when we move to the multi-cloud, multi-cloud computing help in distributing workload across different cloud regions, improving reliability and reduce latency. So however, the existing multi-cloud schedulers are mostly centralized, which introduces serious privacy and scalability challenges. Which I just want to introduce the federated learning here, which is going to resolve these training models locally and sharing only the model updates instead of sharing the raw data. Like if we are using different clouds, so they won't share the raw data to that cloud. They will share the only model update to that cloud. Like the raw data will be trained under the that cloud environment, and the updated model will be shared to the central aggregator. So what's the problem we face here? Like real-time smart mobility applications cannot tolerate high delays or failures. Single cloud solutions are insufficient, and existing multi-cloud approaches rely on centralized schedulers that requires full visibility of execution and workload. This may lead to privacy risk, violation of data law, scalability bottleneck. Like we will face if we have a huge amount of data, we don't able to figure out like which cloud environment we need to we need to share the data, like which cloud environment will be working on it. So in smart city environment, traffic and mobility data is extremely sensitive and cannot be shared across the cloud providers. Therefore, there is a strong need for decentralized, privacy-preserving task scheduler framework that optimizes performance without sharing the raw data. So I have few literature surveys. Like I have reviewed recent research where I got to know that there is centralized multi-cloud scheduling, privacy-aware scheduling, federated learning based. While these works provide valuable insights, they suffer from notable limitations, like mostly rely on centralized decision making. Privacy is either partially handled or ignored. Smart mobility uses are rarely evaluated. Additionally, many approaches do not support task abstraction for real-time data. So these gaps directly motivate the design of our federated decentralized scheduling approach. So my reserve objectives, like what is my reserve objective? Our reserve objective has the 5 main objectives, like privacy by design, use federated learning, eliminate centralized schedulers to improve scalability and fault tolerance, support geo-aware and latency sensitive scheduling using smart mobility data, enable a continuous feedback loop, and adaptive scheduling decision. So when we talk about the privacy by design, we are ensuring that no raw data will be shared across the cloud. And if you are talking using the federated learning, then if you use federated learning to collaborate the learning scheduling policies. So we aim to combine global intelligence with local autonomy. So this is my proposed architecture diagram. So in this diagram shows our system architecture. Like a smart mobility data is collected from the sensors and the traffic sources. This data converted into scheduling tasks and sent it to the nearest cloud region. Each cloud region uses a local model-based scheduler, local ML-based scheduler, make autonomous scheduling decisions. Only the model parameters are sent to a central aggregator. The aggregator applies federated averaging, FedAv, to create a global model. The updated model is distributed to all cloud. At no point is raw data, like raw traffic or execution data shared, so privacy is fully preserved. So no, like our methodology is based on four principles, like federated learning, scheduling, fully decentralized architecture, no raw data sharing, lightweight task brokering. This allows efficient and privacy-aware scheduling in dynamic multi-cloud environment. So yeah, so we have gone for the federated learning process. So first, each cloud trains a local model using its own traffic data. Before processing with the model training, I have taken a data set and I have did a pre-processing so that we can correct the data set, like all remove the all null values and um, I have cleansed the data set. Then we have moved for predictive learning process. So second, only model weights are shared with the aggregator, not the data itself. Third, the aggregator combines models using the weighted average algorithm. And finally, the updated models are sent back to all clouds. This process is repeated over multiple training rounds, improving the scheduling quality over time. So this approach ensures collaborative learning without violating privacy constraints. So here we can see for a global aggregation, I have used this algorithm. First, I have just aggregated from the data set, I extracted priority, task, priority, and the different columns priority and how they are just going to distribute the data set. So after that, we uses the weighted average for local model training with this formula. Then, yep. So now I came to experimental setup. During my completing my research, I have used what data set and what tools I have used. So we have evaluated our approach using a smart mobility data set containing features like speed, congestion, signal state, and energy consumption. Experiments were concluded in a simulated multi-cloud environment with multiple cloud regions and virtual machines. We compared 4 approaches like random scheduling, rule-based scheduling, local machine learning, and my proposed predictive learning approach. Evaluation metrics includes execution delay, energy consumption, privacy leakage, communication scalability, where we
Excuse me,
can,
sir.
yes.
Just a reminder, you have 2 more minutes of presentation time left. Thank you.
Sure. So now we move to result and the performance analysis. I have did the task abstraction where our approach uniquely supports task abstraction with predictive learning and no data sharing. For scalability, predictive learning, predictive aggregation improves the scalability compared to centralized solutions. And for privacy, the system ensures strong privacy preservation across all clouds. If we compare with all the models like random, rule-based, and local ML, so they basically work on centralized. But as I have multi-cloud task scheduling, I have proposed MFL, so they don't share the raw data. They only share the model update. So it gives the enhanced security, like privacy. While rule-based scheduling may show some if we talk about the performance, while rule-based scheduling may so slightly delay, the proposed approach receives better performance with significant higher privacy and scalability benefits. So my conclusion is to conclude this work presents a privacy-aware, predicted multi-cloud scheduling framework. Scheduling decisions are made locally, eliminating decentralized controls. Predictive learning enables collaborative optimization without processing the raw data. The system supports real-time, geo-aware, smart mobility workloads. And some future works are there. We can use the deep enforcement learning for adaptive scheduling, apply model compression to reduce communication overhead, delay the system on real cloud platform AWS, Azure, or GCP, extend the framework on the edge cloud environment. Thank you.
Thank you so much for your presentation, sir. I now request our session chairs if they have any questions for you.
I would like to ask what is actually sent to the central server during the learning process? Are the parameters on the slide 13?
So, sir, the data set I have taken for it is the like smart city mobility. So once I have gone for the pre-processing and I have just using that data set, I have took some speed, energy consumption, some parameters. I have just doing the pre-processing. We have extracted that parameters. On that parameters, we have moved forward so that we can train the model within the cloud in regions and only share the model updates. It will be trained using the for FL schedulers, and after training the data, it will only share the model updates to the central aggregator.
Okay, thank you.
Dr. Kotwal, any questions?
Yeah. See how your framework handles when the cloud get failure.
Um, Sir, as I told you that this is decentralized. So if one cloud is not working, so the FL will there is a central aggregator which is linked with the model. The model updates are shared to the central aggregator. So it will handle if one cloud will be down, it will share to the other available cloud. It is just based on the scalability. So scalability, if there will be any failure, it will share to the available cloud environment.
So how the federated scheduler differs from the traditional distributed or centralized? How it differs?
Sir,
Already we having the distributed, then afterwards centralized. How the federated scheduler it differs?
sir, it differs previously what the traditional schedulers does. When we get the raw data, we share it to the raw data, but we are not sharing the raw data. So we are training the model within the cloud environment, and we are sharing the model updates to the central server, and that is the central server is receiving the model updates, and they are sharing to the only the model raw model updates, not the raw data. So.
Okay, that's
Okay.
all from my side.
Thank you so much for your presentation, sir.
Thank you.
One of our previous speakers is back. He was facing some issues. So our next presentation would be done by Akshay Kumar from the Datta Meghe Institute of Higher Education and Research in India. And the title of the research paper is Modern Approaches to Crop Monitoring, Enhancing Productivity and Sustainability. Sir, I request you to kindly start presenting.
Okay, sir. I present our PPTs.
Yes, you can share your screen now.
Yeah, my screen is visible.
Yes, it's visible now. You can start presenting.
Okay. I am Akshay Kumar. I am from Datta Meghe Institute of Higher Education and Research. And my paper title is Modern Approach to Crop Monitoring, Enhancing and Productivity and Sustainability. And my co-author is Professor Reena Satpute, Edit Young, Kumar Gaurav, Sanjeev Kumar, and Professor Sudhir Modesa. And there is a outline of our presentation. First of all, introduction. Second is a conventional crop monitoring practice. Recent technology developments in crop monitoring. Introduction to sustainable practice. Challenge of crop monitoring techniques. Future challenges in crop monitoring. Conclusion and references. One second. Introduction. The human civilization is anchored on agriculture because it has become one of the most important determinants of food security, economic growth, and social stability. The current state of modern agriculture has been critical crossroad with the various complexity of the climate changes, security of the resource while including and the rising incidence of extreme weather conditions like droughts, floods, and inconsistent seasonal cycles. Historical consistent standard crop surveillance have led to adoption of new state-of-the-art digital technology in the uh, prod- production like IoT, AI, and UVS. The paper is reviewing of the recent method of crop monitoring with crit- critical analysis of their method, technology farming, and the effectiveness of their operation and their sustainability. Conventional crop monitoring practice, the the foundation of agriculture was the trad- traditional monitoring, traditional crop monitoring, visual inspection, and handy surveys. Example, yeah, allowing stunt growth or pest infections. The techniques are very common in a small scale and subsistence agriculture because the sophisticated technology of our machine are not affordable. Limitations of traditional method, time consuming and process, manual efforts, labor uh, intensive, uh, prot- prone insecurity and limited scopes. And next is a recent technology development in crop monitoring. Current crop surveillance combines several novel technology which allow to continue continuously monitoring crop, identifying anomalies early, and maximize resource usage, like remote sensing technology, Internet of Things like IoT, unnamed aerial vehicles, uh, artificial intelligence and machine learning, and uh, comparative analysis and research gaps. Introduction to sustainable practice. Uh, Sustainable agriculture has become an important need to be face rising world food requirement, climate fluctuation, uh, resource exhaustion, and environmental det- deterioration. The current technology in crop monitoring is transformative in facility sustainability through the incorporation of the precision farming, data incentive decision making, and resource efficiency management in practice, like data driven decision making, uh, minimization of resource wastage, environmental advantage, and next is challenges of the crop monitoring techniques. The main problem here is the high uh, intentional cost of the investment, technical and skill level, data privacy and security, and infrastructure of the connectivity, especially in rural of the developing areas. The initial high cost of investing in hardware, software, and integration of systems are among the biggest obstacle to the uptake of modern crop monitoring technology, like im- improper application of the farming techniques and reduced labor supply, data privacy and security concerns, infrastructure and connectivity issues in remote areas, and requirement of a standard evaluation structure and standards. future of the future in crop monitoring, future challenges in crop monitoring, advancing in sensor technology and AI, integrating with the blockchain for a transparent supply chain, and policies and incentive for adoption. Next is the conclusion. Uh, precise farming provides the possibility to make a decision in real time, utilize resource optimally, and protect the environment with the help of remote sensing, IoT, drone, and AI. It helps farmers to easily identify the pests and disease infections and deficiency nutrients among the disorder and implement corrective measure to minimize losses. Third, third is a precise farming converts water and chemicals beside the ensuring the practice of farming is in accord with the objective sustainability and therefore mitigation the effect of climate changes. And the major obstacle to implementation are their high resolution potential of the agriculture sector, high initial cost, technical skills requirement, and data security. It requires the corporation in making of this technology more accessible, affordable, and user friendly to farmer. Their adoption uh, facil- may be facilitated by policy intervention, which includes uh, these you see outline above can be addressed to achieve food security across the global increase agriculture resilience and remote sustainability activities wish list safeguarding the environment to secure the ever increasing populations. And these are the reference of our paper. And thank you.
Thank you so much for your presentation, sir. We now ask our session chairs if they have any questions for you. Mr. Luthor, any questions?
My question is from a practical point of view, which of these technologies do you think is the most realistic entry point for small and medium-sized farmers? IoT sensors, drone, remote sensing.
Is a IoT sensor is a more sustainability because it's working like a hardware device to monitoring which chemicals and mm, seeds are required in according to environments.
Okay. Thank you.
Dr. Kotwal, any questions for our speaker?
No question. No.
Okay, thank you so much for your presentation, sir. We have two more presentations of our previous speakers who are back right now. So our next presentation will be done by Mr. Shaikh Shafi from the B.V. Raju Institute of Technology in India. And the title of the research paper is An Intelligence System for Vehicle Recognition, Ignition Access and Real-Time Alerting for Theft Prevention in Smart Cities. Sir, I request you to kindly start presenting. Thank you.
Sorry, sir. Sorry for the inconvenience.
Okay, are you his co-author?
Yes, sir.
Okay, okay. Please continue presenting. I'm sorry to interrupt.
Okay, sir. Where many vehicles are theft increasing rapidly in India, with lakhs of vehicles stolen everywhere. Where traditional key securities like a GPS tracking are not fully secure. So we proposed the biometric-based ignition system using IoT.
In this system, we use the ESP32 microcontroller fingerprint sensor, where it works in two stages: door access, engine ignition. If an author unattended occurs, so we use real-time alerts. Real-time alerts are sent with a location. The system improves security, reliability, and convenience. These are the literature reviews where we use previous system were used for GPS and GPS for tracking locations, the vehicle, GSM for communication, and IoT protocols like MQTT providing efficient communication. Some systems uses Raspberry Pi Arduino. These are the previous papers in literature. This is the block diagram of the proposed work. Our system works in two phases. First phase is fingerprint. Our system works in two phases. First phase is fingerprint is stored in memory, then we use the place the finger. System checks the authorization. If it is correct, ignition is allowed. If in second phase, if fingerprint is invalid, the request sent to owner's mobile. Owner can approve or can deny the or he can block the access. And also unauthorized attempts trigger alerts. This improves the security, flexibility, and reliability. And this block diagram refers the shows the working of the system. Main components are ESP32, fingerprint sensor, GSM, and IoT module, LCD display. This is the flow where user fingerprint ESP32 and decision, engine control, and plus alerts. And these are the results where first we can see the system first asks the user to place a finger. LCD displays put finger. Then after successful capture, LCD shows enroll. Then it means that fingerprint is stored. And the second and figure 4 that explains that during the authorization, if fingerprint matches, LCD shows lock open. If does not matches, LCD shows not found. Access is denied. And it is uh, fifth finger. LCD shows engine on. If authorization is accepted, LCD will be on and engine will be on, door lock will be on. That means IoT dashboard time activity. SMS alerts are sent to engine on and lock open unauthorized attempts. Uh, Unauthorized attempts will be sent to the owner's mobile location along with the location and GPS tracking everything. This is the final prototype of the hardware system where we proposed, and side one figure 7 is the LCD display where for the registering SMS shows the mobile notification alert where engine is on, lock open, or unlocked or not found, fingerprint is not found. These are the applications where the system can be used in securing the vehicle ignition and personalized driver profiles, anti-theft systems, fleet management, driver verification, and smart vehicle services. These are the advantages where key advanced includes high security, fast and easy access, personalized usage, real-time alerts, IoT ignition, and theft prevention. When it comes to conclusion, the system improves vehicle security significantly, and two layers authentication increases safety. Real-time alerts help in quick responses. It reduces theft and unauthorized access. Future improvement is add encryption for better data security. We can add the better data for the future. These are the references where we taken from the previous years and research papers and sources used for this project. And thank you. I'm ready for the any questions.
Okay, thank you so much for your presentation, ma'am. I request our session chairs if they have any questions.
See, ESP 232, fine. How efficiently it works if I compare it with the Raspberry Pi Arduino? Because
works.
See what exactly it you are going to alert the message. So how efficiently it will going to work when I use the ESP232?
Where ESP32 is the fast and Bluetooth connection is very fast. where compared to Raspberry Pi, mini computer supports very high applications. ESP32 is a microcontroller for good sensor control automation. So we use the ESP32 for building fast Wi-Fi connection and Bluetooth, fast responses, real-time control, and it has a less sources of usage.
ESP32, it's a microcontroller or microprocessor?
Microcontroller.
Mr. Lator, any questions for our speaker?
Yes. Do you see the solution more viable for vehicle manufacturers or maybe as an aftermarket product or for a fleet management companies?
I could not hear you, sir. Can you repeat the question? Sorry.
Yes, my question is, if do you see the solution is more viable for vehicle manufacturers or aftermarket product, for example, in a fleet management company? Can you hear me?
Sorry, sir. Hello, can I hear you, sir?
Yes, can you hear me?
No, sir, I don't know.
Oh, sorry, I have some problems.
Yeah.
So no questions.
Thank you,
Okay,
sir.
no more questions, right? Okay. So we will now be moving on to the last presentation for this session. So our last presentation will be done by Kamala L from the Gitam deemed to be university in India. And the title of the research paper is Optimized GAN-based data augmentation for enhanced lung cancer CT classification. Ma'am, I request you to kindly start presenting.
Good morning, everyone. Is my voice audible, sir?
Yes, ma'am, you are clearly audible.
Okay. So good morning, everyone. So I'm Kamala L from Department of Computer Science and Engineering from Geetam University. I am research scholar as well as assistant professor in the same department. Today, my topic is about optimized GAN-based data augmentation for enhanced lung cancer CT classification. So this is the flow of my presentation today, the agenda. So being started with the focus is on detection of lung cancer using CT images. So why lung cancer I have chosen is because it is one of the leading cause of death across the world, and it is one of the fatal diseases that has been identified, and it has a high mortality rate. The major gap here is the identification or the diagnosis of the diseases is bit complicated when compared to other kind of diseases, and early detection might save patients' lives. So for that reason, I have chosen this topic. And apart from this, CT images, because in lung cancer detection, they mainly rely on clinical data and also CT images. They don't undergo for PET scan or X-rays to detect the lung nodules. So my work mainly focuses on CT images, and also I'm using advanced technologies like deep learning, CNN, and also I'm combining it with many machine learning algorithms. Here I'm mainly focusing on the generative adversarial networks. What was the motivation behind this was, so the reduced missed cancer cases, improved sensitivity, that is a parameter that I have chosen across the images, handle the class imbalance that is there in the data set, and build a clinically reliable system based on the size of the lung nodule. So mainly I am focusing on the data. So coming to literature survey, there is extensive research that has been done with respect to GAN over the period of years. So the first, I have listed a few of them here. So image augmentation, many papers have been published over the year from 14, even prior to that. So generally data sets they consider is CT or X-ray images, and most of the papers that you can see here, just a minute. Just a second. Most of the paper that you can see here is based on the limitation with respect to optimization of GAN. So that has become the research gap that I have identified. Even in the next slide, you can see a set of paper that have been used advanced GAN technologies, and here also few new GAN technologies like Warstain GAN was introduced, but later the optimization was not done properly, and hence their better result could not be achieved. So that is the next thing. And coming to the research gap that I have, there is no optimization done to the date, and they focused mainly on accuracy but not on sensitivity of the data set, and the statistical validation is not be done, and there is false negatives that has been always ignored in the data set, that is the false identification of the images. So concern to my problem statement, so these are the proposed research, mainly identify the class imbalance, fewer malignant samples, high false negative rate can be deducted, and reduce sensitivity. How I can reduce the sensitivity? So this is the proposed architecture where I have a image data set. So image data set mainly I have taken from a library of Iran Oncology, and also I have collected from the private hospital in our state. So what I have done is I have pre-processed the image, resizing, removing the noise, everything is been done. Later, the machine runs in two tracks. Track A is by baseline and track B is GAN augmentation. So in track A, you have the training, but there is no GAN used. Training is being done using CNN. So then you have the baseline training and performance evaluation. When you come to track B, you have the GAN augmentation. That is, if I talk about GAN, it is called generative adversarial networks, where you have a generator and a discriminator. Generator gives the images, and the discriminator identifies the images, has any noise or any problems, and help to generate more realistic data sets without any false things in that. So what I have done is I have used this hyperparameter optimization. So that hyperparameter optimization uses FID technique there. So this FID technique, right, so is Pritchett inspection distance, which identifies the different slices of the images. Then you have the synthetic image generation, then minority class augmentation of the data set. Then I have used both CNN and GAN optimization techniques, and I have done performance comparison for the statistical testing. After doing it, I have done Namer's test to evaluate the performance. So this is the proposed architecture. Then whatever the steps I've explained is being implemented or listed here in this slide. And also the pre-processing step, whatever you can see in this diagram, right after the CT image data set undergoes so much of resizing and pre-processing the noisy data in the images, where you have pre-processing step and training and testing step. And this is the experimental setup that I have done. And as I told, I have taken the data set from institutional repository and also public archive. So institution, I have contacted a hospital and I have fetched the data set. So that's the process. And this is the result for the proposed GAN. Then with the existing methodologies that are already there, and I have found it to be better when compared to the existing technology after combining GAN with CNN. So these are the graphs that have been generated with respect to the first graph, which shows about the baseline and GAN augmented performance. And here you can see through ROC curve how GAN augmentation has been improved. This is the extra training time caused by GAN. So with respect to different epochs that I have run across. And this is the performance of GAN augmented CNN. So GAN along with CNN can do better than anything else. Then talking about the conclusion, GAN improves the classification performance with respect to data set, effective for class imbalance classification, clinically relevant approach when compared to the existing methods. And what can be done as a future work is 3D CT analysis. So where you can have multiple slices of the images fetched from the repository and detect it. I have applied only for lung cancer, so it can be approved for any kinds of diseases where CT scanning is involved, and also federated learning can be included. So these are the references I have gone through. So thank you for giving this opportunity.
Thank you so much for your presentation, ma'am. I now ask our session chairs if they have any questions for you.
Yeah, which GAN architecture you have used?
Sir, I have taken the WGAN GP architecture. So it is called Varstian Generative Adversarial Network with Gradient Penalty.
And see, you are working on the lung cancer. Fine.
Yeah.
How did you ensure that the synthetic CT images are diversity or clinically realistic? How you ensure?
Sir, the first thing is one set of data set. I have used two different data sets. One that is there in a institute repository from an oncology center. The other one is I have collected personally from a hospital through the reference of doctors. And I have sat with the radiologist. They have certain tools where they see the slices of the image and they have suggested me which slice has to be taken to the work which I am processing with. And then I have moved forward with that, sir, because I am not a medical student and I totally don't identify how a CT is being scrutinized. So I have taken the help of radiologists there and sat with them and have worked with them to identify what can be done in different slices of image and which suits best for my work. So only that
So
slice.
whether you have annotated?
Yes, sir, annotated it.
So which tool you have used to annotate?
Annotated tool is. Sir, I'll just remember the name. Just a minute, sir. Just a minute. The images that I was used was the DICOM images that they gave me. So the tools that I have used is 3D slicer. So where they have helped me, the hospital staff have helped me, specifically the radiologist, to fetch those images, sir. Annotation. And one more thing is they have a IT department that have completely hidden the patient data and only I have the images with me. So I'm not able to see the patient personal data also. So it is completely hidden. They have done that work and they have given the images to me because I need to use it in my publications and my work. So they have given me the ethical clearance letter and then I have used it.
So whether you have used all the ethics related to the medical file while collecting the data?
Yes, sir. I have given my presentation, I have the documents, I have the ethical clearance, then I have used that data.
Fine.
Mr. Lator, any questions?
Congratulations for your work. My doubts, my question were answered right now. So thank you.
Okay.
Thank you. Thank you, sir.
Thank you so much for your presentation, ma'am. And that brings us to the end of session 7F. I now request Mr. Fernando Lator to give us his closing remarks.
Yes. I would like to congratulate all the presenters here. And I think this Congress are a good example of how technology and research can give us new knowledge and new tools for working in a better future. So all the things I can say to you is congratulations for your work, and I would like to give you my sorry yes my congratulations again, and I would like you to improve your research and thinking how you can put this work in the market. So it's very important to in the next steps to have clarify if you need some kinds of partners, and because the research must be something useful for us, for all of the citizens. So give my congratulations for all of you.
Thank you so much, sir. It was great to have you with us. And now I request Dr. Jamir Kotwal to give us his closing remarks.
First of all, I'd like to thank to the organizing team, right? as well as all the organizer related to the conference, that is Information and Communication Technology for Intelligent System. Then Amog, you also part, fine, and all the participants, they have given the wonderful presentations, fine. And happy to see that each and everyone, they are working in the different fields, fine, to get some better and to give to the real-time society the solutions, fine. So thank you, you all.
Okay, thank you so much, sir. I sincerely thank all of our authors for their excellent presentations and contributions towards this session, and all our participants as well for being a part of this international conference. I hope this session was informative and interactive enough for all of us. And on behalf of the entire team, I would like to thank all of you for your support that you have shown during the 11th edition of this conference, and all the previous versions as well. And we will be more than happy to host all of you back for the 12th version in 2027. Just a small announcement, all the presenters will be getting their digital certificates via email within 2 working days, and the publications will be live within 7 to 8 months. So kindly cooperate with the team of ICTIS. And I also thank both our session chairs for chairing this session. This is just a small token of appreciation on behalf of Team ICTIS and Global Knowledge Research Foundation. Once again, I thank all of you for your valuable presence. Just a small request. I request all of you to kindly switch on your cameras for a quick snapshot of this conference, and we're done. Okay. Thank you so much. Have a good day.
Thank you.
Thank you very much. Have a good day.